Hello, AP Statistics. This is section 10.1, two sample z-tests for differences in population proportions. You're going to need graphing calculator, your note sheet, tables, paper and pencil. Once you got those, we're ready to go. All right, we're going to study Chantix. Chantix is an FDA-approved medication used to help patients quit their habitual use of tobacco. All subjects who participated in the study were over the age of 18 and had previously smoked at least 10 cigarettes per day. Of the 1,023 subjects who participated in the study, all were randomly assigned to be part of one of three treatment groups: the Chantix group, the Bupropion SR group, and the placebo group. We will assume that the patients were equally distributed to one of the three groups. However, we will only investigate the results of the Chantix group with the placebo group. If you would like the full research study that was eventually submitted to the FDA and approved, you can find it right here. Okay. Further, once it was approved, there was a commercial on TV that talked about this medication that had to be prescribed by doctors, and it is still there. Okay. If you look at the commercial, you'll find that it has some pieces of data in it. And if you look in the original script, that data is consistent with the research that you found from that website. Okay. Now, I just took a piece of that original work, and I want to again investigate Chantix versus the placebo from the very first set of trials. And again, if there's 1,023 subjects divided into the three groups, there should be 341 members for each of the sample sizes. Okay. And it was also found that 44% of the people who participated and used Chantix quit smoking, okay, after 6 months, whereas the placebo had only 18%. Okay, and I hate to say only 18% because that's still pretty big in my eyes when you consider that they only received a placebo that didn't really chemically alter anything in their body that said you didn't really need cigarettes. Okay. Nevertheless, 18% versus 44%. And what we want to know is, if I'm a research company, did the 44% have a statistically significantly bigger value than the 18% from the placebo? Okay, now, as I look at that seems kind of obvious. It looks like 44% is much bigger than 18%, but there may be moments when we do research and we're comparing proportions where, the values are a little bit closer together, and we need to know, is it appropriate to say that one is statistically significantly bigger than the other, or one is statistically significantly smaller than the other, or maybe just different from each other? Okay. So what we're going to do again is a test to figure out, is it appropriate to say that one is statistically significantly higher, okay, than the other? Okay. So this table is fairly complete. The only thing I don't have are the number who quit. Okay, and that's easy to do. I can just take the sample size 341, multiply it by 0.44, and that gives me 150.04. And then the same thing here, 341, multiply it by the 18%, and let's see, that gives me, if I remember right, 61.38, which is just 61. Okay, and we're just going to round down for now. You'll see why that's of value in a little bit. Okay, so what can I do to either support the claim that maybe one is statistically significantly bigger than the other, or maybe say that there isn't evidence for that? We will use an inference test, just like before, using 5 steps to come up with a conclusion. Okay, and it all begins with, again, a null and alternative hypothesis. Okay, however, my population proportion will not be set equal to a parameter. Okay, they're actually going to be set equal to each other, and it's going to look something like this. Okay, my piece of C is the true population proportion of people who would quit smoking using Chantix. Okay, whereas the piece of little p is the true population proportion of people who would quit smoking using the placebo. Okay, notice that the null shows that there's really no difference in proportions. Okay, that any difference that there may have is strictly just insignificant. Okay, that they're fairly close together. Okay, the alternative suggests that the Chantix group actually has a higher proportion. Okay, and as a drug company, that's what I really want to show, that my intervention is purposeful, okay, and that my proportion was actually larger than having a placebo group. Okay, so keep in mind that this equal to sign is always there for our purposes, okay? And again, in your alternative, you'll either have a greater than sign, a less than sign, or a not equal to. Okay, so nothing has changed there. All right, so step one is done. Okay, and now we'll move on to step two, which is conditions. Do we have conditions? We do. Okay. What's even better is we have two sets of conditions. We have one for the Chantix group and one for the placebo group. Okay. Do you have to show work for both sets and identify them with a title like this? Yes, you do. Okay. You have to do both in order to get all the points on your AP test. Okay. So if I think back to random, okay, does it describe anything being random within the work? And I'm going to back up a paragraph. Sorry. And here's what I got. Fifth line down, you can see the random there. It says not only random, but random assignments. Okay. And so I'm going to scroll back. And for the random, I'm going to write random assignment for each. Okay. Now, is that different from just saying random, like randomly selected or an SRS? It is, okay. When you say randomly selected or doing an SRS, what that means is you have a population, okay, and you're using some type of unbiased sampling to come up with a sample size of N. Okay, this can mean that you take every member of your population, writing the name individually of each on a piece of paper, throwing them in a hat, shaking them up, picking N of them out, okay, which is different from random assignment. Okay, which I'm also writing on the top. Okay, and the idea is this, at least through my opinion. Chances are your population here, you're considering all people who are smoking who want to quit. Okay, we were able to take every single potential smoker who wanted to quit. Okay, put their names in a hat and pick out 1,023. Okay, it's just not possible to do that. Okay, there are too many people out there who smoke. However, we did take some volunteers. Okay, and amongst those volunteers, okay, we are able to randomly assign 1 of 3 treatments, either the Chantix, the secondary treatment, okay, or a placebo, okay, and these are all done through random assignments, which I know I wrote above it, but that really takes place in this action between your volunteers to these respective 3 groups, okay. These are all independent from each other, which means once you become part of a group, all right, you don't get to go back into the pool, get replaced, and put into one of the other groups, okay, for another choosing. Meaning you can't be part of the Chantix group and then also be part of the placebo group, okay? It doesn't make sense to do that. Why? Because if you are successful in your smoking or, your quitting of smoking, you don't know where to attribute the success to, okay? So each person only gets 1 treatment. People are not replaced back into the original pot, if that makes sense, okay, as they are once selected to be part of a sample. Okay, so make sure you write random assignment for each. Again, this allows people to know that they're independent from one to the next, okay? Meaning, person who is part of one treatment will not get another treatment. Someone who's in the Chantix group will also not be in the placebo group, okay? All right, second part is 10% rule, okay? And I'm gonna write this off to the left here. Remember, that's typically little n is less than or equal to 1/10 the big N, okay? You only need to do this, okay, if, and I'm gonna draw a little arrow, if you have something that says randomly selected or doing an SRS, okay? If you have a random assignment, this part will not exist, okay? And largely because you are, again, being replaced back in, or sorry, you're not being replaced back into your original pool, okay? There's no replacement. And so that part is left empty if you have random assignment as opposed to being randomly selected or an SRS. And you don't even have to write 10% rule. You can leave it blank. You just don't even write it, okay? Last thing is large counts, okay? And remember, large counts depends on the formula n times p is greater than 10, n times 1 minus p is greater than 10. However, you have to do it for two groups. You have to do it for the Chantix group, and you have to do it for the placebo group. And if we write that workout, okay, we know that all four of those will have representations bigger than 10. In fact, we've done this 341 times 0.44. It's actually up here. It's this 150. Okay, and we did this one over here. It was 61. And these are both the lower percentages between the two, and it's between itself and its complement. So I know these will be bigger as well. Okay, so show your work for it. Make sure you show all four pieces, okay, and identify that they are all bigger than 10. Once we have that, of course, we will say that we do have an approximately normal distribution for each. Okay, and that is your step 2. Okay, so now we're on to step 3, which is our test statistic, and we're going to use a z-score, okay? However, again, we have multiple pieces of data. We have Chantix data, we have placebo data, okay? And we're going to create a z-score equation that involves both of them, okay? Both pieces of data. Now, you'll notice that the p hat sub 1 minus p hat sub 2 are the samples, okay, for the respective interventions. And you notice that N1 and N2 are also representative of each of the two samples, whether it was Chantix or the placebo, okay? Further, you'll also notice we have a p hat that has no subscripts with it. And you're like, is that a typo? And the answer is no, it's not. Your p hat is actually an x sub 1 plus x sub 2 all over N1 plus N2, okay, with no space, or it's actually just one giant fraction. Okay, and these values are actually above. Okay, they're found, and it was good that we found that 150 and the 61 for that table, because that helps us input those and come up with the results. Okay, and so now I can find a value for p sub 1, p sub 2, and all the remaining variables underneath that square root bar. Okay, it's not pretty, but it looks like that. Okay, and you can check that work if you're curious. And if you do the square root piece underneath, you get 0.0354, and on top you get in the numerator 0.26. Now, what does this mean? All right, I'm going to draw my best normal curve. Okay, right down the middle, I've got a 0, okay? And what is that? I don't really have a lot of room, but I'm gonna just put it right here. It's the average of all the Chantix minus placebo samples that could occur, okay? We had samples of good size, 341, but it could be that if we had a different sample of 341 for each, that we may have a different set of proportions on the top, okay? That's the way things go. But sometimes those proportions may be bigger or maybe worse. I mean, not worse, but smaller. But the idea is judging off the null, okay, assuming that they're the same, okay, and that there is no difference between the two, their difference would be 0, okay? And so we'll go under that assumption that the difference would be 0, okay? Now, one standard deviation away will be this 0.0354. Okay, and if you go through and do this math, 26, you're like, holy moly, 26 is gonna be like way out to the right. Okay, further, if I take it another step, it's actually 7.34 standard deviations to the right. Okay, and I don't really want to draw all that. Okay, so I will mark it and then shade to the right. This is actually 0.26. Okay, and I know that's not to scale, but I wanted you to be able to see some type of area. okay? And again, you got to find the area of that region. Now, why did I shade to the right? Well, again, my alternative is a greater than sign. Okay, and if it's a greater than sign, then you'll flow in that direction. Okay, we want to find the area to that sign. Okay, so test statistic is found, 7.34. That is step 3. Okay, and we are done with that. Okay, what do we do with step 3? We take that 7.34 and we find a p-value. Okay, now remember, for a z-score, 7.34 in terms of your normal distribution table, okay, does not go this high. Okay, and I think the highest it goes is 3.49. And when you try to look that up, 3.49 as a z-score gives you a value, I think, of 0.0002 to the right, which means this is going to be even tinier. Okay, and for myself, I'm just going to say that it's about 0. Okay, and that's okay to do. All right, because we know that high standard deviations in a very strong positive direction or a strong negative direction has a strong likelihood of either probably being 0. Okay, so this is step 5. It is off our normal distribution table. Sorry, not step 5, step 4. Okay, and then we're off to step 5, which is writing a concluding statement, which you'll see at this very bottom as it's firing your way. You're going to look at 0 and compare it to an alpha cutoff of 0.05. And here's what I'm going to write. I'm going to say we're going to reject the null because our p-value of 0 is less than my alpha cutoff of 0.05. There is evidence to suggest that the true population proportion of people who would quit smoking using Chantix is higher than the proportion who use the placebo. Okay. Again, notice that this is all in the present tense. Okay. I always like to either reject or not reject the null in the beginning and compare it, the p-value, to some alpha cutoff. Okay, our p-value is super small, so even a value of 0.01 would have been rejectionable. And further, I always say there is evidence either to suggest or not suggest, and I always write it in terms of the alternative, the ha. Okay, which brings up an important point. Okay, you'll notice the way that I wrote my null alternative hypothesis, I believe, gives a very good conclusion at the end. Okay, because we were able to say that we believe the proportion of people who chose Chantix, who choose Chantix, have a higher chance of quitting smoking versus the proportion who would use a placebo. Okay. However, your book will sometimes do this. They will say P of C minus P of P must be equal to 0. And they'll sometimes do the alternative of P of C minus P of A is greater than 0. So they sometimes like to write it like that. That is equally correct. And they'll write their answer that way sometimes in the back of the book. That's also appropriate, but it just looks like a little different, like a little bit different style. Okay, so just know that that is an alternative way to do it. And sometimes for many, the more preferred way, but it's up to you to write it with either style. Okay. All right. That is basically it. We come up with a conclusion. We used all 5 steps. Okay. The only thing that you may want to adjust, okay, is just having the knowledge that you can do steps 3. I'm going to circle this real big, steps 3, and step 4 over here using your TI-84 graphing calculator. Okay. So here's what I got. Top left corner TI-84. I didn't change anything. I still wrote the null and alternative hypothesis. I wrote the same formula that we had before. I wrote the Z that we found, 7.34, our probability of 0, and the conclusion. Okay. However, if you are interested in using your graphing calculator, okay, and I would say that I would be interested in this because it just makes our work just a little bit easier to work with. Okay. I'm always afraid of having big fractions underneath square root bars and bigger fractions of making a silly mistake. Okay. Because I'm a human being, it happens. So what you can do is this. You could say, hey, you know what? We're going to use our TI-84, okay? And what we're going to do is this command. We're going to go to stat, okay? And then we're going to go over to tests. In this case, it is number 6, okay, which is a 2 proportion z-test. Okay, you hit enter on that, and you're going to input the items that represent your X and your N. Okay, I would put them in the same order that you wrote your proportions for your original Z. Okay, and so remember that these two items was like your first p hat. That was for the Chantix, and your second two were for your placebo. Okay, and so those are from our samples. And if you go all the way down to the inequality, remember that we want to follow the sign of the alternative. Our alternative has a greater than sign, so we'll use that. We'll click on calculate right here. Okay, and you get this result. You'll notice that it has a couple of important things, and it looks like there's too many P's in this, but they do exist. The first thing is your Z-score. Z is equal to 7.37. That's very close to the Z-score you have here. The next item that's important is your p-value, okay? And that's just right behind it, just directly underneath it. You have 8.42. And remember, that is not a p. 8.42 is not a proportion. Remember, this e to the negative 14 is really times 10 to the negative 14. If you want to write it like that, that's cool. If you just want to write 0, that's appropriate as well. I would make this easy for myself and just say it's 0. Okay. Are you allowed to write this type of syntax on your AP test as opposed to showing this work? You certainly can. Okay. So all you have to do is do TI-84, which I'm boxing. Okay. You don't have to hit the buttons. Okay. But you do have to say the command. Okay. And then in the end, write the Z. Okay. With the letter with it. Okay. So Z is equal to 7.34. Or in this case, Z is equal to 7.37. They would both be accepted. Okay, and then the proportion, the P, okay, the P value. Okay, either one of those would be fine. All right. Excellent. Now, what else do we have to talk about? Confidence intervals. Okay, so two sample Z interval that looks different from test for difference in population proportions. Notice that I identified the P sub C and the P sub P the same way. Okay. However, the standard deviation is different. Okay. Notice that I no longer have the pool just plain P hat. That guy is gone. I'm just going to use my P sub P, P sub C as well to include into each of these two respective fractions. Okay. So here's the formula. And again, new standard deviation. And you have to know that this is different from the original Z-test that we did before. Okay, so the first part isn't any different. This was in the numerator of our work. Okay, pardon me, I forgot the conditions. Okay, we would normally have two conditions. That's our first step. And why did I forget to do it? Probably because we already did it. Okay, if you have the same conditions as you had in the previous part, then you don't have to do them twice. Okay, so these are already satisfied with our test. So don't do them again. If that happens in your homework where you have to do a test and one problem and then a couple problems later, you have to do an interval, a confidence interval with the same original data, you don't have to restate all the conditions. You can just say, hey, conditions are in problem 6, wherever that was. Okay. All right. Now, pardon me. I'm going to erase this. I didn't know I had that typed there. Let me erase this. Good. Okay. That's the work that you plug in. Okay. You should notice that that is familiar. Okay. This was in our numerator for our Z-score. This, again, is new work. Those 341s are our N's. We knew that. However, we're using the P's, our P hats from our respective sample data. Okay. So the first fraction is for the Chantix. The other one is for the placebo. Okay. Now, what is this? Well, that relates to the type of confidence interval I'm using. Okay. And while I didn't say it earlier, this is a 95% confidence interval. And you'll have to remember the critical values for that. Okay. And so sometimes you see 90%, that was 1.645. Sometimes you have 95%, that is 1.960. And the last one was 99%, which was 2.576. Okay, and so in this case, if you remember, we'll put the 1.96 there. If you have your T distribution table, it's the first row on the bottom, just above the confidence levels that are listed. Okay, so if they give you something other than those three, you can find those on that respective sheets. Okay, all right, if you do the math for this, okay, you get 0.26 plus or minus this guy here is 0.066, if you're curious, and your interval is 0.194 to 0.326, okay? And that is step 2, coming up with the calculation for your 95% confidence interval. And then finally, we want to write a sentence, okay? The sentence reads, we are 95% confident the interval from 0.194 to 0.326 captures the true difference in population proportions for those who would quit smoking, and it gives a good direction. Okay, I said Chantix minus the placebo. Okay, this is a more representative of the alternative way of writing the null and alternative hypothesis, where you have those set equal to 0, and it may fit that description a little bit better, but this is how that one would go. Okay. And I don't know if there's anything else I want to say about it. I think that looks great. This is your step 3. Okay, and you would be done. Okay, now what's the messiest part of all of this? Some would say the conditions, they don't like that. But I'll say this math can again get really kind of laborious, okay, if you had to plug all this in your graphing calculator. Okay, so if you want to skip step 2, okay, and do a little shortcut version of it, here's your TI-84 version of it. Okay, again, that's the original work. Okay, if you want to skip this piece, here are your steps. Okay, you're going to go to stat, you're going to go to test. Okay, and it's tough to see, but I think it's B. Okay, there you go, B. Okay, and it's 2 prop Z interval. Okay, and from there, once you click on that, you got these 4 that you're going to input with your confidence level of 95%. And if you go down and calculate, you get this interval. Okay, you'll notice that this interval is very similar to what we found here. Okay, so what do you have to write? Well, you'd have to write TI-84. I'm going to put this on the very top just below my picture, and then of course that command. Okay, so follow-up question that they often like to ask is, based off this interval, okay, was there a difference in proportions from the Chantix group versus the placebo group? Was Chantix statistically significantly better than the placebo group? Okay, well, if they were the same, okay, with respect to a population, if they were the same, that would suggest that their difference was 0. Okay, and if you look at being the same as 0, notice that that does not occur. Okay, 0 is not within, okay, the confidence interval. Okay, and what does that mean? It means that we believe Chantix had a higher proportion of patients or subjects who were able to quit smoking versus the placebo. Okay, the proportion who took the placebo. Okay, so there you got it. Again, I encourage you to use the graphing calculator method to find steps 3 and 4 for your test, or step 2 for your confidence interval. Don't forget to show this little piece of work to let your reader know how you came up with those data results. Okay, but once you do, then you're in great shape. Okay. All right. Again, there's your sentence for that. And there is your assignment. Okay. So if you have any questions, you'll let me know. And I hope you have a great day. And we will talk to you again soon.